very much. I don't know. Yeah, that works. Thank you very much for the introduction and for this excellent conference. It's been very interesting all the day. And yes, I live in 5 countries, like Spain, France, Holland, Hong Kong, and now here. And Sweden is by far the coldest. That's for sure. So today I'm going to talk about VR video formats and UX. So this is very simple presentation about VR and design. So don't expect anything that is complicated and technical. Myself, José Somolinos, I'm a UX product manager. That means that I care about the product life cycle. So I follow, like markets, competitors, and other trends. But basically, I'm a designer. So it's in the UX part, the designer. So you will see that because I don't have any bitrate comparison tables or those graphs, like diagrams. That's infrastructure that's very challenging. It was fun this morning when it was Will from Akamai who say, "No, yeah, these 2 presentations that we watched before, yeah, they were nice, low introduction. Now we're gonna go deep." And then it was like, "Oh my god." And now with Jay was like, "No, let's, I'm gonna put no math, like 3 p.m. Soft thing." Oh my, have you seen those? This is what you consider simple. So I work for Accedo. Accedo is like it's a global company. Probably we're leaders into application development and everything that is around for multi-platform and streaming, VOD. We are based in Stockholm, here in Mediaplatsen. We are a bit in all the regions, 16. And related with VR, we do many other things. VR is just one part. Related with VR, we do design, development, platform, white label applications. So we know a little bit about that. So coming back to this video that you present, how many of you have watched video in VR? Okay, how many of you have watched more than 30 minutes in a row? Okay, I can say that the same. Yeah, that's good. But as they said, they are very bulky and very difficult for now. But we'll see that will change. So conventional video is what I call like what we are seeing today in the video VR industry. So the first one is rectangular video that you say, "Oh, this is not VR." Yes, if you can watch it in VR, that will be VR video. Actually, there are many of our customers asking for solutions like that. Back in 2015, we did this video application for watching video in 16:9. What is the advantage of having that kind of video that is already produced? So this is kind of a good advantage. You can watch any video that you already have, and how we, as a designers, how do we do a good experience of it? Because, it will be just very boring. It's just the video sitting there, right? So we fill it with metadata. We put the information on the right. We create navigation patterns on the bottom so you can change the video and the experience a little bit more enjoyable. This is, sorry about the quality, those are GIFs. This is another video application that we developed for National Basketball League in Australia and New Zealand. And the same, they wanted to have video in 16:9, but not 360. So what we did, it was like a way to interact and take, like in this case, you have some analytics that you can ping and while watching video in 16:9. The same here, we had the chunk the video with the highlights. So people at the same time that they keep watching live, they can watch the small highlights in their hand. So the space around you is filled. So 16:9, but use it a bit more clever. 360 video is what you all maybe have tried, and you think that this is VR video. We see that it's maybe not. So this is our white label application for VR video consumption with 360. Here, as you control it with a remote control, like in the VR, just click and you call this menu. So this menu, it brings you like some metadata, information about that, so it's covering the video, right? But in some solutions, some applications, like this one that we developed for Deutsche Telekom, it's a video application for watching concerts and videos. It was developed for Google Cardboard, so we didn't have the remote control. So we needed to create a navigation system and a menu that it won't bother you the experience while you're watching, but you can also interact. So you have the cardboard applications, they are controlled with a gaze controller. It means that when you look, you have like a pointer where you can interact with things. So all this menu needed to be like far from what you are watching, in this case, the concert. So having a little bit of interaction to change cameras, get more information about the group, and so on. And now 180 videos, that it could be considered like a downgrade of 360, why you will have 180 when you can have 360. But for me, it's a refinement of 360 video, actually. I mean, if you're looking to me now, you're not looking behind you. So most of the things that we are watching today, they have an interest point, especially in some kind of content, like a sport or music. You are just watching in front of you. You don't need to have behind. Probably some like a very interesting narrative experience for drama. They will be like all around you, but normally everything is in front of you. So why waste all this space filling it with something where you are not going to look at? Save that space and increase the stream by, for example, doing 3D. As we said, there's always like one good and one bad. Who wants to spend some bit rate? I mean, you're always talking about, I'm going to, 1% extra in the streaming to put that guy eating a fry, right? So first we need to think, okay, what is important? What are we going to send? And that is what Google has been working on. It's a VR format. It's called VR180. Has been launched like last April, I think. And the first cameras are arriving now at the end of the year, I hope. So this video has something very particular. It's only 180, so you see only like that. But it's also compatible with regular screens. So you can be watching a TV without the distortion, only a little bit. It's not like this 360 that you are watching your phone and you move. No, this is like a regular. You can record in front of you. If you're watching a TV, you will see it perfectly. If you watch it in a VR, you will move. So this is a good advantage. The content producers, they can use that to produce once and deliver 360 in regular YouTube. Okay, so so far we are tight for 360 video. This is like, as is the common, we are using some kind of what we call projections for using, because we are using VR is so new that we don't have yet formats that they are specific for VR. When you see VR cameras, they're just a bunch of 2D cameras put together. When you see 3D videos, VR video stream, it's just a 16:9, like this one, 16:9 video stream. This is not created specifically for VR. So we have, when creating this projection, the same problem that the map creators had. You have a sphere around you that you're recording a video. You want to project that into a 16:9 square. So those have small problems, like you see, laser. Yeah, you see here these circles. They have more pixels. They are bigger than those circles here. So and they are distorted. That means that all of this space is like the bottom and the top is not where you're watching, but it's the one that has more pixels. So it's the same. Your stream is not optimized. People like Facebook, they are creating new ways to create projections for the video. So the quantity of the important pixels, the thing that you are looking at, is represented into the stream. So here it's a little bit better, but you still have some distortion. And again, the center where you're looking at is the smallest part. To solve that, this is how it looks. a cube map projection. To solve that, the latest that they have done this year is a barrel projection, which is just they have a cylinder all around you and they cover it with the two lids, right? So the portion of the video that is important for you is bigger. But when you have that, this is even not enough. There are ways to improve that. So now the video has, the part where you're looking at has a good amount of pixels, better than the top and the bottom, but there are ways to improve that. One of the things is adaptive streaming. I think last year there was a talk here about that specifically. And you see here this square, so that represents what you are looking at. So you only receive in HD what you are looking at. All the rest is just a low bandwidth stream that you receive. So you save. You save bandwidth. And the other thing is a very clever way also to do that is offset. So with algorithms, they know where you're going to look at, and then they adapt the number of pixels at every second to give you more data of where you're looking at. So all of that combined made like an incredible savings in 360 video compared with just a player that plays all of a sphere around you. So, and now we get to the non-conventional video, where it's like the next step is what VR video first steps after the chronology. Our body has some physical properties, so we can move like that, turn, and the devices, they recognize that. The Samsung Gear and the Daydream, they don't do, they just have these three. But the rest, if you crouch like that, all the scene will change, and you will feel that natural. So I'm talking about that because when this is how it looks like a regular stream or 360 3D. This is all the information they are sending, only that, pixel by pixel, one by one. So this is one eye, and this is another one. It's like distorted like that. So the 3D image that you are seeing is just a model in your mind. There is nothing 3D there. It's just your mind that is making the trick. But there are some computers taking the same images, or many different images, and creating what they call a depth map. So with that depth map, they know how far are objects, and try to, and they see their shapes. You can see like the black means closer, right? So this is very interesting because it allows us to add a layer of information on top of the video that before we didn't have. If you see here, if you are able to see that shape, then it means that I'm able to attach some metadata for that specific person. And if I'm watching that video and I have my remote control into VR, I can point at him and choose more videos from him. Or if he's a basketball player, I can have statistics about him. So that will revolutionize a little bit the way that we understand VR, making it a little bit more interactive. But all these videos, they have like a problem. Is that the video is recorded from a single point. So the projections and everything is just one single point. If we are moving here, we are losing this reality. If you're crouching, the camera is still here. So your point of view hasn't changed. And then the body feels that it's not real. On the other hand, virtual reality is like when you have games. If you imagine a game, you can walk, and then all the different projections and the perspective that you have, they will change. So your body will feel that you are moving. This is the major difference. So the next step is taking these depth maps, and what people are doing, the quality is a bit bad, but they create a 3D model. Is what one of the other previous speakers mentioned. Is what we call the volumetric video. So every single frame is actually a 3D model. And that kind of changes everything. Because If you are able to have a 3D model, it means that you can change lighting, that you can remove objects, or even add objects. This is like a fake object that they are adding. This is a representation. So in that context, we are able to recreate and add interaction to the scene, change conditions, and that opens like a new frontier for us designers and video editors. This is fantastic. We are breaking a little bit the paradigm of just like a 2K, 4, HD, 4K, 8K. This with that kind of thing doesn't have. It's not relevant anymore. It will be another thing. This is what we are waiting for VR development. And this brings us to the future of what video could look in the future. Augmented reality in AR. This is Buzz Aldrin in one of the apps called Holo. And as you see, it's just a small person there. It's a small representation, hologram, like a Princess Leia. No? Everyone's dream to have it there, sending the message. So in the future, video is going to change so much that we're not able to recognize it. When we're having the news, why do we need to have a background? Why we cannot have just the guy of the news having a coffee with you in the morning in front of your chair? Or when we are seeing some gymnastics in Olympic Games, why we cannot have just the gymnast guy here jumping around? You don't need the rest. So this kind of video that now looks like surrealistic is going to be like that. I mean, when you will have like a stand-up comedy, bring it to your living room. That's going to be, I hope. So, and this kind of environment is what a few companies, like this one is AI, they are creating studios for recording that type of video, the volumetric video. So far, it's a very expensive way to do it. All of that, each of these cameras cost, I don't know, but quite a lot. I hope that soon we'll have a possibility to have like a low-end cameras able to create 3D models at least in front of you. I've seen like yesterday with a phone, they were able to go around the forest and create a 3D model of the forest with just a phone. So I imagine in the future. So I hope that all what you were talking today about bit rates and things applies also for this, and we'll have good VR videos in the future. Thank you very much.
So let's open up for some questions. We have the microphones ready. Oh, there's one.
Hi, I've used VR, and one problem is how you might feel and the latency between what you see and how you move. What's your view of reducing that poor experience that might make you nauseated?
So you feel the nausea because your brain feels that you are moving, but your body does not, right? So one part of this nausea is caused by... Is it me?
I don't know.
One part of that is because of this, is what I explained, the 6 degrees of freedom. If you have a device that is only 3 degrees of freedom, so it means that when you move like that, the camera position doesn't move. It means that... Thank you. So it means that the representation that your brain is going to do, when you move, it doesn't match the movement of the video. So having this volumetric video is going to reduce the nausea, hopefully, because it's going to be way more realistic for your brain, even if you don't feel it. There was even like some experiments about what happened when you put a virtual nose on your device, on the video game. It helps reduce the nausea because even if we don't see it anymore, we are seeing it, the nose. So when they remove it, the brain is saying, oh, there's something wrong. When you put it down, okay, nose is there. It's like this. So just that. Jay, please, no vectors.
No, this is an easier one. So I'm curious about your sense on how you're following the industry. Like, obviously, Google has been doing a lot of its work. Facebook's been doing a lot of its work. Some interaction between the two, some collaboration, but not always. So from your perspective, I'm wondering, like, what's the easiest way for folks to keep up? Have you been going to any sort of group standards bodies, things like that make it easier?
Oof. Now we see from a video point of view, I know from a development point of view, now we are struggling because every time that there is a customer coming and saying, hey, I want to have an app, it's like, okay, in which platform? And that's a blocker because it's not the same. Even if you can use Unity as a way to have a common background, and after you can export and develop for PlayStation, or for HTC Vive, for Google Cardboard, or Daydream. For video standards, I really hope that there will be a standard for this volumetric thing. Because the 360 is something that more or less everyone has nailed. It's like a kind of done. But this kind of workflows, like the one of Facebook with Otoy, I think is the other company doing the video processing. I mean, they need to be clever enough to gather everyone at the beginning before it's too late and we go to different paths. I think Adobe has started to do another path that scares me. So when you come back, please put them together in a table and say, guys, stop the shit. Any other question? Just as a candy for the end, I Google and the numbers of the bit rate of volumetric video are 50 times higher than HD. So yeah, you have some numbers. Thank you very much.
Yeah, okay, thank you.